diversity factor of 50% in theater lighting means that, on average, only 50% of the total connected lighting load is expected to be operating simultaneously. This is because in a theater setting, not all lights are used all the time. When performing electrical calculations, if a 20 amp circuit is used, you should only use half of the allowed wattage in your calculation. This means that you should design for a maximum load of 10 amps calculated as 20 amps multiplied by 0.5. The National Electrical Code, or NEC, does not explicitly mention a diversity factor for theater lighting. However, it does state that the connected load shall not exceed the rating of the circuit as per NEC section 210.23. Therefore, it is implicit that the diversity factor should be considered when sizing the circuit. For example, if a theater lighting system has a total connected load of 20,000 watts, the circuit should be sized for a maximum load of 10,000 watts, calculated as 20,000 watts multiplied by 0.5. To determine the current, you would divide the power by the voltage. Using a voltage of 120 volts, this would require approximately an 83.33 amp circuit. 10,000 watts divided by 120 volts equals 83.33 amps. This calculation demonstrates the substantial impact of applying the diversity factor. Several additional considerations are necessary. Firstly, the diversity factor can vary depending on the type of theater, the number of lights, and the typical usage patterns. Secondly, it is important to consult with a qualified theater lighting consultant to determine the appropriate diversity factor for the specific project. Thirdly, the NEC also requires that branch circuits for luminaires, meaning lighting, be protected at not more than 20 amps as per NEC section 410.33. Finally, it is recommended to provide additional circuits beyond the minimum required to allow for future flexibility and expansion. In summary, understanding and applying the diversity factor correctly is critical for safe and efficient theater lighting design. Be sure to consult with experts and adhere to the NEC guidelines. When planning theater lighting, one must consider several electrical factors to ensure a safe and efficient system. The diversity factor plays a crucial role in these calculations. The diversity factor, as previously described, accounts for the fact that not all lighting fixtures will operate at their maximum capacity simultaneously. This is particularly true in theatrical settings where lighting is used dynamically to create different effects. In practice, the diversity factor allows you to size electrical panels, circuits, and wiring based on the expected actual load rather than the total connected load. Using the total connected load can lead to oversizing, which is not only costly but also inefficient. To elaborate on the electrical calculations, consider the following detailed steps. Firstly, determine the total connected load of all lighting fixtures. This involves summing up the wattage of every light in the system. Secondly, apply the diversity factor. Multiply the total connected load by the diversity factor, which in this case is 50% or 0.5. The result is the maximum expected load. Thirdly, calculate the current. Divide the maximum expected load in watts by the system voltage to determine the current in amps. For example, using 120 volts, the equation is amps equals watts divided by volts. For 208 volts, the equation is amps equals watts divided by volts, divided by the square root of 3, which is approximately 1.732. For 277 volts, amps equals watts divided by volts. For 480 volts, amps equals watts divided by volts, divided by the square root of 3, which is approximately 1.732. Fourthly, size the circuit breaker. Select a circuit breaker with an amp rating that is greater than the calculated current. The NEC requires that the circuit breaker be sized to protect the wiring and equipment. Common practice is to use a circuit breaker that is 125% of the continuous load. Fifthly, determine the wire size. Use the NEC tables, such as those found in NEC section 310.15, to determine the appropriate wire size for the circuit. The wire size must be adequate to carry the calculated current without overheating. Consider factors such as the insulation type, ambient temperature, and the number of current-carrying conductors in the raceway or cable. Sixthly, calculate the voltage drop. Ensure that the voltage drop from the panel to the farthest lighting fixture does not exceed 3%. Excessive voltage drop can cause dimming and reduce the performance of the lighting. Use voltage drop calculators or software to perform this calculation. Seventhly, ground the system properly. Proper grounding is essential for safety. Follow NEC Article 250 for grounding requirements. Ensure that all lighting fixtures and metal enclosures are properly grounded. In addition to these calculations, consider the following practical tips. Use energy-efficient lighting. LED lighting is highly energy efficient and can significantly reduce the overall electrical load. Consider using dimming systems. Dimming systems can further reduce energy consumption and provide greater control over the lighting levels. Plan for future expansion. Provide spare capacity in the electrical panel and circuits to accommodate future lighting additions or upgrades. Label all circuits clearly. Proper labeling makes it easier to identify and troubleshoot circuits. Perform regular maintenance. Inspect the lighting system regularly for any signs of damage or wear. Replace any damaged components promptly. Engage qualified professionals. Always engage qualified electricians and lighting consultants for the design and installation of theatre lighting systems. They have the expertise to ensure that the system is safe, efficient, and compliant with all applicable codes and standards. Now let's delve deeper into the relevant NEC sections and how they relate to theatre lighting. NEC Section 210.23 pertains to permissible loads for branch circuits. It specifies that the connected load shall not exceed the rating of the circuit. This is where the diversity factor becomes implicitly important. Even though the NEC does not explicitly state a diversity factor for theatre lighting, adhering to Section 210.23 requires you to consider the actual load that the circuit will experience. NEC Section 410.33 states that branch circuits for luminaires shall be protected at not more than 20 amps. This limits the maximum size of the circuit breaker for lighting circuits. When designing theatre lighting, it is common to use multiple 20-amp circuits to distribute the load and provide flexibility. NEC Article 520 covers theatres, audience areas of motion picture and television studios, and similar locations. It provides specific requirements for wiring, grounding, and equipment in these environments. Some key provisions include the use of metal raceways or metal-clad cables for wiring, the provision of emergency lighting, and the proper grounding of all metal enclosures. NEC Section 520.4 covers wiring methods. It requires that wiring be installed in metal raceways, metal-clad cables, or non-metallic raceways encased in not less than 2 inches of concrete. This provides mechanical protection for the wiring and helps to prevent fires. NEC Section 520.27 covers border lights and proscenium side lights. It specifies that these lights shall be suitably guarded to prevent contact by persons or objects. It also requires that the wiring be installed in metal raceways or metal-clad cables. NEC Section 520.43 covers receptacles. It requires that receptacles used for stage lighting be rated for at least 20 amps. It also requires that they be equipped with a grounding contact. NEC Section 700 covers emergency lighting. It requires that theatres be provided with emergency lighting that will automatically illuminate in the event of a power failure. This ensures that occupants can safely exit the building. In addition to the NEC, there may be local codes and regulations that apply to theatre lighting. It is important to check with the local building department to ensure that the design complies with all applicable requirements. Let's consider a more detailed example to illustrate the application of the diversity factor and NEC requirements. Suppose a small theatre has the following lighting load: 2500 watt incandescent spotlights, 10 1000 watt incandescent floodlights, 4 1500 watt follow spots, and 6 750 watt LED stage wash lights. Firstly, calculate the total connected load. 2500 watt spotlights equals 10,000 watts. 10 1000 watt floodlights equals 10,000 watts. 4 1500 watt follow spots equals 6,000 watts. 6 750 watt LED stage wash light equals 4,500 watts. The total connected load is 10,000 watts plus 10,000 watts plus 6,000 watts plus 4,500 watts, which equals 30,500 watts. Secondly, apply the diversity factor. The maximum expected load is 30,500 watts multiplied by 0.5, which equals 15,250 watts. Thirdly, calculate the current. Assuming a 120 volt system, the current is 15,250 watts divided by 120 volts, which equals 127.8 amps. Fourthly, size the circuit breakers. Since NEC section 410.33 limits branch circuits to 20 amps, multiple circuits will be required. The number of circuits needed is 127.8 amps divided by 20 amps per circuit, which equals 6.35 circuits. Therefore, a minimum of 720 amp circuits will be needed. Fifthly, determine the wire size. Use NEC table 310.15 to determine the appropriate wire size for each 20 amp circuit. For example, using type THHN conductors in a raceway, a 12 American wire gauge copper wire would be suitable. Sixthly, calculate the voltage drop. Ensure that the voltage drop from the panel to the farthest lighting fixture does not exceed 3%. This may require increasing the wire size for longer circuits. Seventhly, ground the system properly. Follow NEC Article 250 for grounding requirements. Ensure that all lighting fixtures and metal enclosures are properly grounded. In this example, the diversity factor significantly reduced the required circuit capacity. Without the diversity factor, the calculations would have been based on the total connected load of 30,500 watts, which would have resulted in much larger circuit breakers and wire sizes. However, it is essential to verify that the assumed diversity factor is appropriate for the specific theatre and its usage patterns. A higher diversity factor may be appropriate if the lighting is rarely used at full capacity. Conversely, a low diversity factor may be needed if the lighting is frequently used at or near its maximum capacity. In summary, designing theatre lighting involves a careful consideration of electrical factors, including the diversity factor, NEC requirements, and local codes. By following the steps and tips outlined above, you can ensure that the lighting system is safe, efficient, and compliant with all applicable standards. Remember to consult with qualified professionals to ensure the best possible outcome. Furthermore, consider the advancements in lighting technology when designing a theatre lighting system. LED lighting has become increasingly popular due to its energy efficiency, long lifespan, and versatility. LED fixtures consume significantly less power than traditional incandescent or halogen fixtures, which can further reduce the electrical load and energy costs. When using LED lighting, it is important to select fixtures with appropriate color temperature and light output for the intended application. LED fixtures are available in a wide range of color temperatures from warm white to cool white, and it is important to choose the right color temperature to create the desired atmosphere. In addition to energy efficiency, LED lighting also offers other advantages. LED fixtures have a much longer lifespan than traditional fixtures, which reduces maintenance costs. They also produce very little heat, which can help to reduce the load in the HVAC system. Furthermore, LED fixtures are dimmable, which allows for greater control over the lighting levels. When designing a dimming system for LED lighting, it is important to use dimmers that are compatible with LED fixtures. Not all dimmers are compatible with LED lighting, and using the wrong dimmer can cause flickering or other problems. Another important consideration is control system. Modern theatre lighting systems often use sophisticated control systems to manage the lighting. These control systems allow the lighting designer to create complex lighting cues and effects. Control systems can be either manual or automated. Manual control systems use physical controls, such as faders and switches, to adjust the lighting levels. Automated control systems use computer software to control the lighting. Automated control systems offer greater flexibility in control than manual control systems. They can be programmed to execute complex lighting cues automatically, and they can be integrated with other theatre systems, such as sound and video. When selecting a control system, it is important to consider the size and complexity of the theatre. A small theatre may only need a simple manual control system, while a large theatre may need a more sophisticated automated control system. It is also important to consider the skills and experience of the lighting designer. A lighting designer who is familiar with automated control systems will be able to create more complex and sophisticated lighting designs. In addition to the above considerations, it is important to pay attention to the aesthetics of the lighting system. The lighting should be designed to enhance the overall look and feel of the theatre. The lighting fixtures should be chosen to complement the architecture and decor of the theatre. The lighting should also be designed to create a visually appealing and engaging experience for the audience. When designing the lighting, it is important to consider the different types of performances that will be held in the theatre. A theatre that hosts a variety of performances, such as plays, concerts, and dance performances, will need a more versatile lighting system than a theatre that only hosts one type of performance. The lighting should be designed to be flexible and adaptable to the needs of different types of performances. In conclusion, designing a theatre lighting system is a complex and challenging task. It requires a thorough understanding of electrical principles, NEC requirements, lighting technology, and aesthetic considerations. By following the guidelines and tips outlined above, you can create a lighting system that is safe, efficient, versatile, and visually appealing.